Okay, hello guys, nice to hear from you and gladly see you in New Year, right? Okay, today we start a little of physics. So mathematics will take a little from time to time because mathematics and physics are very closely connected, right? So the lectures will be called Spaces and Times, and this will be Spaces and Times number 1. Okay? And of course you probably heard that physics is about studying nature, right? All kind of nature. Actually, physics is the basis of all sciences, all natural sciences. Like all other sciences like chemistry or even biology, it's all based on physical laws and actually couldn't be derived from laws of physics. The process of the derivation is very complex, but it's actually it was done. So we know now how physics explains all these effects in chemistry, in biological things, in our bodies. The same as in stars, planets, everywhere, animals, whatever you choose. And also physics somehow connects with this informational theory in a certain way. Information is not material, so it's not natural, in like if you talk about this, it's natural only in our mind, right? So information starts from mind of people or other, maybe mind of aliens or whatever you can imagine. But it's closely connected with the matter. So it is not matter per se, but it's still somehow connected. We'll talk a little about it later. Okay. So today we'll start from the beginning. And the beginning is a little, it's the main difference like of natural sciences from the mathematical sciences. Mathematics usually don't care about like real measurements. You can apply mathematics to measure, like, for example, the distance, right? Or the speed of the car or whatever. But this is already some natural things what we say about. So it's mostly about physics, not about mathematics by itself. So mathematics is not talking about units, so-called units of measurement or any systems of these units. But physics concerns about it, and it starts from this. From the beginning. So today we'll start from the units, and the units, of course, are the main units are measurements of space and time, or spaces and times. You will see there are could be many spaces and many times. So we talk about measurement units. Units. There is a system of this measurement unit system, and the basic international system, it is called C. So what do you think it means? SI. System international, right? So this is international system of units, right? And these units in this international system, they start from units of distance. So distance, you know what distance is, right? Yeah. And distance in this system is measured in meters.
What about centimeters?
Okay, meters. M. The short is M. Meters. We'll talk about this. We'll talk about this. The other units. But the main, according to the C system, distance measured in meters. You should remember that because physics is very strict with this. So distance measured in meters. All other units are derived from the meter, like centimeter, decimeter, megameter, kilometer, lots of other units, femtometer, and etc. So then we have time, of course, right? So the second important thing in physics is time, and time is measured in seconds. Seconds, again, S, short S. So time, S, distance. Oops, I'm sorry. Distance meter. Now, in addition to this, the third main thing is mass. Mass, you probably heard what mass is, right? So when you're buying something in the store, right, like butter or potatoes or whatever, they all have their weight, right?
Yeah.
Weight. And weight is very closely connected with mass. We'll talk about this later, how it is connected. But anyway, if you say like in Canada, Canada actually is using system C. So mass is measured in grams or kilograms, right?
Yeah.
Kilogram is 1,000 of grams, right? But anyway, in C, the main measurement unit for mass is actually kilogram. Kg. Oh, maybe I'm not sure. Do they use it? But maybe usually use big K, kg.
Yeah. Yeah.
And K means kilo, right? So mass, but usually they use in physics usually use small k, so kg. And this is like kilogram. Kilogram. Okay. All these things, these are basic. These are basic units, right? So, but when we talk about some other units, remember we can use some other things like kilogram already. Kilo, right? It means 1,000. So 10 to the power of 3.
Yeah.
And of course, because it's grams, so it's 10 to the power of 3 grams, right?
Yeah.
But it happens so that in C still use kilograms, so it is like a main unit. So everything is based on this. Just remember that. That's how it goes. That's just people agreed to use it like this. So kilo means 10 to the power of 3, right? You talked about centi, right? Centimeter, for example. Centi, the prefix kilo means 10 to the power of 3. Centi means 10 to the power of minus 2. You know what minus 2, remember? What it means?
No, I remember that calculator. Actually, I wrote it down.
Remember?
Yeah, have you do that?
So it's divided. Actually, you
Oh.
made it 1 divided by 10 to the power of 2.
Oh.
Minus means this. Always go like this. The other things like which is used like deci. Maybe you heard this decimeter, right?
A 10.
Decimeter, it's 10. Yeah, so 10 to the power of, oh, I'm sorry, not 1, minus 1. So it's from meter. Decimeter, it's 10 to the power of minus 1. So again, it is 1 divided by 10, right?
Yeah. Yeah.
So now you can say what kilometer means, right? Kilometer is how many meters?
Sorry, 10. I meant 1,000 meters.
1,000 meters, right. Kilogram is what?
1,000 grams.
1,000 gram. Okay, kilosecond.
Kilowatt? 1,000 seconds?
1,000 seconds, yes. What about like centisecond? Okay, centisecond. What it means?
1/10 of a second.
Huh?
I meant, sorry, 1/100th of a second.
100, exactly, yes. 100 of that. And decisecond is, like you said,
Decisecond is 1/10 of a second.
1/10, right. Now also we have a lot of these things, but the main are kilo, centi, deci, and some else. Some, for example, is mega. Mega is pretty used thing. It's 10 to the power of 6.
What?
Mega. Like probably you remember in computing bytes, megabytes. Probably you heard this word.
Yeah.
Megabytes, kilobytes. Kilobytes mean of course 1,000 bytes. Oh, it's a little different, but we're not talking about. But according to this system, mega is 10. So megabytes is 10 to the power of 6, right? So what is mega meter?
A million?
Million, right? And megasecond, yeah,
A millimeter. Oh,
Million.
it's a million.
and megasecond is million of meters, right? What else? Megacenti, that's a mega. There is also giga. It's like 1,000 more, but we won't talk about this. So you may take a look and talk with your papa with this. There are lots of these names, these prefixes, right? So, but you should remember them because we will meet with them pretty often. All these things, right? Now. The main things that we have in physics also are called energy, okay, we have time, probably we have momentum,
Energy? You can't convert it to mass.
energy, momentum, and for now, huh?
Oh, dang it.
Frequency and speed, or also acceleration.
Speed. Oh, you were right then. You were right. But it's not the law.
You just said I was
No,
right.
you were not. It's speed. You're right. No. Sorry.
That's okay. So energy is a potential, like you know the word potentially. So it's your ability of something to make some changes in outer world, like a big changes. So the energy is a measure of this change. If you have lots of energy, you can create a lots of havoc, right? Lots of chaos around, lots of things also to do. So to go like very far, your car should keep energy in your gas, right? So lots of energy. To fly somewhere like to Venus, you should have even more energy, you know. So energy is stored in the gas or whatever, any fuels or in many places. Energy is a very important thing, but this is like your potential, your ability to do something, right? And energy is measured in, okay, energy is measured in joules. J.
Oh, yeah, joules.
Joules, okay. Joules?
Ah, joules?
Joules or joules? I'm not sure about pronunciation. Antosha, you remember?
Joules.
Joules, okay. Okay. So joules, okay. Energy is measured in joules. And there's an interesting law actually.
Watts.
Huh?
Watts.
No, okay, well, we'll think about laws a little later. Okay, energy is measured in joules. And energy actually usually is measured like this. For example, if you have a speed, you know what speed is, right? Speed is how many meters you pass per second, right? Per some interval of time. So speed is measured in how many meters? So meters divided by seconds.
Meters per second.
Yeah, velocity or speed.
Dude, I told you it's velocity.
Yeah, you may talk about velocity. Atosh, what is, by the way, what is the correct term in English?
Speed. What you're doing is speed.
Speed,
It's not
right?
velocity.
Speed. But you can talk about velocity too. So speed is meter divided by seconds. So how many meters per second? It is written like this: meter divided by second. Right. Also, we have a certain thing which is called acceleration. Acceleration is closely connected to speed, but it's a change in speed. If the speed, you see, it's a change in distance, right? So how many meters per second, right? So it is speed is actually, you may say it's a speed of change for distance.
So what do you mean meters times?
But acceleration is the change of speed. So speed may be constant, right? You're running like 100 kilometers per hour all the time, like in the car, right? Without changing your speed. But when you brake, you actually lower your speed, right? You decrease your speed. When you push on the gas, your speed is accelerating. Speed is increasing, and you go faster. So acceleration is the change of speed now. If the speed as it is a change of distance in meters, right? So acceleration is change of speed, and because it's change of speed, it's measured in certain things. How many meters per second?
Meters divided by second divided by
And
second.
divided by second. And if you divide it, if you remember mathematics, it will be meters divided by second square.
Mm-hmm. Remember that?
Oh,
We did that.
So you see the units are closely connected, and they are come out from one another. Like for speed, it's easy to see. First of all, speed is meters divided by seconds, right? So we have meters, we have seconds, we have divided. Acceleration is meters divided by seconds to the square, to the power of 2, something like this. But also, okay, momentum. Momentum, it is measured like mass. Jesus, I forgot the name. Как будет умножение? Multiplied. Just mass multiplied by speed. So this is momentum. This is some physical unit. It's usually it's denoted like P. Mass multiplied by speed. So it is momentum. And your guess, what will be the units of this, of momentum?
What are the units of speed?
I'm assuming speed is
And units of mass?
Kilograms.
Kilogram.
No, it's mass.
And momentum measured in?
So, what are the units for mass?
Momentum and energy.
We said no. What is the unit for mass?
The unit for mass is kilogram.
And the unit for speed?
Joules.
No. We just did it up there.
And meters per second.
That's right. So kilograms times.
M over S. Did kilograms times M over S.
Oh, correct. Kilograms
By itself. Hold on.
Yay.
by M and divided by S, right?
Yep. But how is it? I don't get how is it?
This is M divided by S and multiplied by kilogram. I'm sorry, this must probably we should write here like M like this, not to mess. Okay, this is mass, this is speed. So mass is kilogram and multiply meters divided by second. It will be kilogram by meter divided by second. Got it?
Yeah.
Remember fractions, right? So this multiplied by kilogram. So it will be like this. Okay, now we have what? We have also, I was talking about energy, right? And energy is like, we'll go a little simpler way. Energy, like kinetic, is called kinetic energy. It is one of forms of energy which is connected to the moving thing. Like if your car is moving, it has an energy in it when moving. And the higher is speed, the higher is energy. It's easy to understand because like if your car is standing, it will not create any disturbance around, right? But if your car is moving with a speed like 100 kilometers per hour and it hit the wall, you know what will happen, right?
Yeah. Stop.
So lots of explosion and all that time. All this energy goes, right? So this is called kinetic energy. And kinetic energy is measured like this. It's usually denoted by big E. So E is mass multiplied by speed squared and divided by 2.
Okay.
This formula comes from so-called Newton mechanics. Newton is one of the greatest physicists in history. He lived in 17th century in Britain, so he created a mechanic and also a lot of other things, and he derived this formula. So looking at this formula, we're just talking about formulas for now. We're not talking like seriously about it. We're just talking about units. So if you look about this thing, right, what do you think are the measure unit for energy?
Units.
Like mass multiplied by square divided by 2.
Okay, did it kill, okay, wait, what's V?
А где это? А где?
Wait, what's V again?
Huh?
What's V again?
V is speed.
Okay, that would be, okay, did it kilograms times speed squared over 2?
Yeah, but what are the units? No, the units don't have the numbers. So kilograms, you're right. But what are the units for speed?
Did
Velocity is V, usually used for velocity,
Did it
and the acceleration. Huh?
express squared over 2?
There's no numbers. But you're right.
Yeah, but you said right. Yes, just no numbers are used. So the measure units is
Do you get that, Tata?
you got it?
Huh?
It's kilogram by
What is the unit for speed?
meter squared and divided to s squared.
Oh, no.
Kilogram from mass, and this is squared speed or velocity, right? And squared speed is m divided by s squared, both are squared.
Wait, that was mass before, I thought that was a 2.
Got it?
Yeah.
So this is energy.
This meters.
And also we should talk probably about something like frequency. Frequency.
So let's talk afterwards. Just don't forget. Ask me.
Frequency. It is measured. Frequency is a periodical, like so oscillation. Something comes up and down like a wave, or like a clock going around, and around periodically, right?
Yeah.
So frequency are measured in two ways. Usually it is so how many oscillations or how many these vibrations or rounds something will take in a second, because the main time is second, right? So how many? And it is measured in s minus 1, so it is 1 divided by s.
How many times per second? Whatever it is you do.
Second to the power of minus 1. So per second, something per second. And this is usually called Hertz. So because of the name, was a guy, the German guy, whose name was Hertz. So Hz. You may use it or may not. The main thing is that in system C it is second to the power of minus 1 for the frequency.
Yeah.
Okay, so this is like main thing. You better remember this. You just try to actually, these things should be memorized. So you try to memorize these things. It's not that many of them, but you try to memorize, because you will be meeting with this all the time. So try to memorize these units, right? Okay, so and then now we talk just a little, because I have some questions to you, right? So I'll give you some.
I don't know. Maybe because we started late. I couldn't get things working on my side.
I give you some formulas which comes from physics. They're fundamental formulas, and why I'm giving them, we're not really talking about them. We just we are talking about them regarding the units. But they are fundamental formulas. They are in the main core, the main fundament of the whole physics. So better to know them. Some of them actually you remember. So probably you remember this Einstein formula. Energy E is mc squared, right?
No, over 2.
mc squared. And C is fundamental constant, which is, it happens so that this fundamental constant is the speed of light. So it is called speed of light, but light is a physical phenomenon, and C is a fundamental thing, you will see the fundamental, why it's so fundamental. Not only energy is connected with the mass, so you may say that each mass has certain energy, and each energy has certain mass. So mass is connected with the energy. But another thing for this C is actually, for when we talk about units, is actually that it may be used to measure distance in the units of time. Because C is fundamental, it never changed. It's in all systems, the speed of light is the same, or called, also they say it invariant, so it's changed nowhere and no time. So you may use it in connection with this time, T and M, or certain meters. So meters. Seconds and meters. And the relation to this is that CT is the same as meter. So speed of light multiplied to the time, it's equivalent to the distance. It's easy to understand when you see the speed of light is never changes, right? So if the light goes from A to B and it takes some distance, for example, some amount of meters, right? It takes certain time to pass it. Certain time, like for example, 300,000 kilometers. How much time will take for light to pass this distance?
Fast the speed of light. How fast is the speed of
Bro,
light?
ask Laura.
How fast does the speed of light go?
You don't remember?
No.
Okay, ask Papa.
299799998.
Oh, okay. Simple, just 300,000. And
Yeah.
so it's very close to 300,000 kilometers, right?
Wait. How fast does it go?
Давайте до 979 24 58 на 38 метров в секунду.
How fast does it go?
Say it again?
How fast does the speed of light go?
300,000 kilometers per second.
1 second.
So each second it passes 300,000 kilometers.
You just said that, yeah, 1 second.
Or you may say that 1 second. If you say about second, using time, using a speed of light as a universal, it's called universal constant. Universal constant. Like the first universal constant is C, right? So speed of light. So for 1 second is 300,000 kilometers, and the main unit is meters, right? So it's 3 to the power of, can you calculate? How many 300,000 kilometers to 10 to the power of?
300,000 minus 3.
How many zeros?
There's 5 zeros in there.
So 10 to the power?
50, but this is kilometers, we need meters.
10 to the power 5.
Kilometers.
10 to the power 5 kilometers.
But now convert to meters.
And now meters, we use meters in C, right? In system C.
Convert it to meters.
10,000 meters to the power of 5.
No. How do you convert kilometers to meters? Times? How many? Yes. Which is 1,000 times 10 to the power.
8. 1,000 to the power 8.
Right.
Guys,
I'm confused.
guys just said that.
I really got
Good
it.
job, guys. I kind of figured it out.
I don't get it. How do I get that number?
Каждый молодец.
So 1 second is equivalent to 3 to the 10 to the power of 8 meters. And this thing,
Oh, yeah.
because it's connected with light, it is, they call it light second. Light second. Or you can use just second. You say second. If you use it as a measurement, as a measure unit for distance, right, it will be this kind of meters. 1 second. The same thing, if you use this formula, right, you have this speed to the squared, right? You can measure energy in the units of mass, and of course multiplied by this. And you can calculate how many energy is in 1 kilo, or how many joules is in 1 kilo, and whatever, right? Now another formula is again for energy, and it is very simple. It's H by omega.
H by what?
This is omega. This is called omega, and this is connection energy to the frequency. Omega is a frequency, and H is called Planck constant, for the name of Planck, the German guy who actually found this formula.
Hormone?
And again, yeah, this, the formula, right? This is formulas, right? So again, what you see, what is here? Energy can be calculated by some frequency, and also energy can be calculated by mass, right? So because those are the same energies for any object, right? You can say that mc squared equals Planck constant to the frequency.
But
Okay, so you can not only say how many energy is in the mass and how many mass is in the energy, but also somehow those things are connected with the frequency, which is measured in, if you remember, it is second minus 1 to the power of minus 1 to 10 to the power of minus 1.
Energy can be measured two different ways.
Yeah,
The same energy. It means that
same energy, yes, same energy.
Get that? All right.
And also there's pretty interesting formula. Again, I will write it for you. This will be interesting for you. This is R, like radius, like,
Oh yeah.
which is G, 2 ohms, 2G, M divided by C squared. G is called gravitational constant. Gravitational constant, G, it's 2G M divided by C squared. And R is a very interesting radius. It's a radius of black hole. It's fundamental thing too. It's very deep in science. I'm not going like talking really about this formula, just writing them here, right? It's very deep, and it's connected to any mass. If you have some mass, M is mass, right? You can calculate the radius of black hole. So if you put this mass into that size of this radius, nothing can come out of it. Probably you remember about such things.
Yeah, I'm sorry about this. Vita stepped out to the bathroom. Can you repeat what you said?
Sure.
So that formula, the last formula that Data put down,
yeah,
R equals 2G times M over C squared.
yeah.
R is the radius of a black hole. How big a black hole would have to be to have a mass M. G is the gravitational constant, C is the speed of light. So
Ah!
for any mass, you can calculate the radius of a black hole with that mass.
Did they actually use numbers from it using this formula?
Well, yeah, if you want,
Yeah.
if you want to see how.
If you put there like for that's just these things, okay? And now because we are finishing, right? There are questions. Can you write them?
Yeah, hold on, Katyush, get up.
I can write them. I mean,
Can you write them?
I have neither handwriting than you, so yes.
Okay. No,
but this is what
Take your notes.
Well,
Take your
don't
notes.
you mind taking it out on the computer?
I usually do, but Katya, get a notepad.
Then I'll be back.
Katya, you're gonna lose this.
I won't.
Where's your notebook? Okay.
Alright.
Okay? Ready? Okay, now guys, you know your weight, right? I hope. Every one of you.
Yes.
For what? Oh, wait.
Your weight. How much you weigh? Right?
Yeah.
Okay, so the first question. What for each of you? What are your frequencies?
Well, there is.
Each of you not only have your weight, but you have your frequency. Fundamental physical frequency.
But
Which is oscillations, you know, something oscillate around you. We'll talk about what is it. It's very interesting thing what is actually oscillating, but right now you just what you have to know that something is oscillating, like you are a wave of a certain type.
right
And
now,
what is the frequency of this wave?
2E equals a Planck constant.
Guys, this is questions for you not to solve now, right? You
No,
cal
but we're writing down the formula. I don't remember the
yeah, you calculate it. You calculate it, okay?
Okay, fine.
Later, okay?
Okay, we'll do it.
Now?
No, not now. Not now.
Next.
Okay, second question, guys.
Lesson.
Second question.
H times. No, I want to write down the formulas. Like they won't remember the formula. 2E equals.
Guys, Antosha, you write it later, okay? You write, and for now you write questions. You can find formulas if you miss them. You can you can see it everywhere. They are fundamental formulas.
Our frequencies. Okay, fine.
So okay, what the frequency each of you, right? Each of you calculate for yourself and compare, right? Okay, and think about what frequency is, and also the second question is what is your personal Schwarzschild radius of black hole? So if you become a black hole, what would be your radius?
What is our black hole radius?
Yeah, personal. Okay, and the third, okay, you wrote it, and the third is how many seconds is in your personal black hole radius?
How many seconds is in our black hole radius?
Yep. Or you can call it light seconds if you want.
How many seconds?
Seconds.
Is it from the kinetic energy formula?
No. Remember, time is connected with.
No, but which? I don't remember.
Actually, actually, you may, Antosha, for you, there is a so-called natural. I'm talking about natural system of units, or relativistic system of units. Actually, it's the most fundamental system of units of all. Like C, it is just agreement, international agreement, right? And natural system, it's agreement in nature. Inside nature itself, there is a certain agreement. And this system is made like this. You put C, speed of light, equals to one constant, equal to another constant, to the speed of, to the Planck constant, and equals to the gravitational constant. And all of them equals 1. If you make it like this, you can calculate all these things which I asked to you, but you can calculate them other way, using just these formulas. But just for you to understand, when you're using these formulas, actually you are using this system. C equals H equals G equals 1.
Right, that's fine. But
And you may think about it too.
can you write down the formulas?
All these formulas, these are formulas. They are here.
All right. Write down these formulas that you see there, Katya.
What's the one for
So E equals mc squared.
And also
I know formulas.
write this for units. This is also for units. It's not formula, but for units it is like this. Ct equal m, equal distance, equal meters.
What do I write down?
What is C?
C is speed of light.
Speed of light? Okay.
I'm already confused.
Hold on. Formula. So write down E equals mc squared. You see it right there.
Meters, seconds.
I can't take this all right now.
That's fine.
All right.
So fine. E equals Planck constant.
You see the formulas, guys, or I'm not sure.
Yeah.
Okay.
Yeah, we can see them. Yeah.
All right.
R, which is the radius of the black hole, equals 2g
All right.
times m over c squared.
M over C squared.
Не забудь
Yeah,
спросить на
Macy, what
следующем
you
уроке
wrote down?
ответы.
That's enough. That's all we need.
Okay, guys. Happy calculating.
Okay.
And I'm finishing the lesson. We'll see you next, but we'll talk